Okay, students, now we'll continue with the circuit breaker series of lectures on circuit breaker. And today we will discuss about the types of circuit breakers. So now uh, we know that there are different types of circuit breakers, but based on what they are, I mean, said that they have these types. So usually the circuit breakers are categorized based on the arc quenching medium used in them, or the phenomena used for arc quenching in the circuit breaker. And for different type of circuit breakers, this phenomena is different. So therefore, the type of circuit breaker also changes. So what actually happen is that, I mean, you know well that there are two metal contacts inside the circuit breaker. So one contact is fixed and the other one is moving contact. So as long as this power system or the electrical network is working in steady state or normal condition, so they are completely in contact with each other and there is no distance between them. And suddenly there occurs a fault in a system, so the relay send a signal to tripping circuit. So the tripping circuit basically send a command circuit breakers and the contacts start moving apart from each other and the moving contact start moving back from the fixed contact. So becomes there occur a distance between both of them, between the moving and the fixed contact. And because of that distance and the presence of electric potential here between the contacts, so there arise an electric field. And because of that electric field, we have a plasma that ultimately leads to an arc. So in the circuit breaker, it is required to extinguish this arc that is developed because of the opening of the contacts of the circuit breaker due to any short circuit or overloading. So the main objective is to extinguish this arc as soon as possible and as efficiently as possible. So there are different mediums that are used to quench or extinguish this arc. So what should be the properties of those mediums? I mean, uh, this arc basically produce a huge amount of heat, resulting into huge amount of heat, and that heat may uh, damage the circuit breaker contacts, for example, moving or fixed contacts. Furthermore, the presence of arc is due to the presence of highly ionized particles or molecules in the vicinity. So if that arc will remain due to the thermodynamic ionic effect, the number of those electrons or the arc creating medium will further increase and it will lead to continuous avalanche process which will result in a high arc or extremely high arc which automatically result in what? It will result in the breakdown, damage, burning of the circuit breaker. So we have to stop this phenomena. So to stop this phenomena, we can use different arc quenching medium. And the property of these mediums should be what? I mean, they are highly inflammable. I mean, to avoid any fire inside or outside the circuit breaker. Secondly, they must be highly electronegative materials so that they can reduce the electrons in the vicinity and in the area or around the contacts of the circuit breaker. Thirdly, they can reduce the temperatures. So they must be environment friendly as well. So these are the basic qualities are the required qualities of any arc quenching medium that should be present around the contacts of circuit breaker uh, during any opening or during its working. So these qualities must be assured so that the arc quenching or the extinguishing of the arc remains effective. So based on these, because to have this, to ensure these properties in a circuit breaker, there are different mediums that can serve this job. For example, oil, then we have air, vacuum can also do it, and in the end, but very effective, sulfur hexafluoride circuit breakers. So, I mean, oil is used for arc quenching, no doubt. Oil is a wonderful medium for arc quenching, but there come some points where, because of the decomposition of the oil, what happens is that due to the decomposition of the oil, there is always a carbon which accumulates on the contacts of the circuit breaker. And due to this accumulation, uh, the circuit breaker contacts may become less efficient. So oil is a good quenching material, but it has this limitation. Then we have another option of air circuit breakers. The air circuit breakers are small circuit breakers and use in low voltage applications uh, where the high voltages or extra high voltages are not there. They are cheap and used for low voltage applications. In air blast circuit breaker, air is blasted or highly compressed air is thrown inside the breakers, which basically open and close the contacts. So this blast of air basically open and close the moving or fixed contacts of the breaker. Then we have vacuum circuit breaker. The vacuum created inside the interrupter or the breaker, and the vacuum actually doesn't allow the formation of any arc or the flow of any electrons because there is no oxygen in the vacuum. So therefore, the vacuum circuit breakers are also an important type of circuit breaker that can be used in the power system. However, they are not used for high voltage levels. The vacuum circuit breakers are usually used up to 33 kV voltage levels. Then for the very high voltage level, we use sulfur hexafluoride gas. The sulfur hexafluoride gas is highly electronegative gas, and its dielectric strength also increases with the pressure as well. So therefore, sulfur hexafluoride gas is also a suitable option, a good option for the arc quenching and extinction or arc in the circuit breaker. So these are the different types of the breaker based on the arc quenching medium used inside. The oil circuit breakers can further be disintegrated into bulk oil circuit breaker and minimum oil circuit breaker. So that we will discuss in the upcoming lectures where I will discuss these breakers in details ton by ton. So we will discuss the relationship between the dielectric strength and the pressure. So we will come along a point that the dielectric strength of any material or any quenching material basically increases with the increase in pressure. So if we will increase the pressure inside the breaker, ultimately the dielectric strength of that material will increase. However, there are certain point below 10 raised to power minus 3 and up to 10 raised to power minus 5. Below 10 raised to power minus 5, the dielectric strength is also very high. And this is because that at 10 raised to power minus 5 atmospheric pressure. At that level of atmospheric pressure, the electrons inside the plasma, if any plasma is created, they are far from each other. They have long distances from each other. So due to this long distance, they cannot, I mean, um initiate the generation of electrons in other molecules of the arc quenching medium. So therefore, uh, I mean, at the very low pressure of, at extremely low pressure of 10 raised to power minus 5 up to 10 raised to power minus 10, the dielectric strength of the medium is also high. However, in the practical circuit breakers, it is very difficult to achieve this much less pressure of atmospheric pressure. So therefore, usually the atmospheric pressures are more than 1 or 10 raised to power minus 1 bars. So we have to keep an eye on this line from here to here, and it is clearly indicating that with the increase in atmospheric pressure, the dielectric strength of the medium also increases. So there is another parameter that is used to basically explain the the dielectric strength or the material that can be used in the circuit breaker for the quenching of arc. So another property that your quenching medium must have, I mean, the first property is that it should have high dielectric strength. So we have proved this thing that with the increase in pressure, the dielectric strength increases. The second property the arc quenching medium must have, that it must have a high deionization constant, because if it has a good ionization constant, then the more electrons we have, the more ionization we have, and it will resultantly ends up into the avalanche effect, which continuously increases more and more electrons. So we must use a material that must deionize with the increase in pressure. So here we can see that with the increase in pressure, the air, helium, hydrogen, CO2, uh, their ionization constant, I mean, increases. So deionization constant increases. So which is a good symbol for circuit breakers. So keeping this graph as a base graph, if we apply this thing to the circuit breaker for SF6 circuit breaker, so this graph is also indicating you the same thing, that with the increase in pressure, so deionization time also increases. So this is a good indication for the circuit breaker that with the increase in pressure, the deionization time also increases. Furthermore, with the increase in pressure, the dielectric strength of the material also increases. So the deionization also increases, and the dielectric strength of the material also increases. So here we have a graph which is actually indicating that a distance between the electrodes in minimum, if that distance increases, what it has an impact on the voltage or the breakdown voltage inside the circuit breaker. So the graph clearly indicates that if we increase the distance between the electrodes, I mean the contacts of the breaker when they are open. So with the increase in the distance between them, the strength, breakdown strength of any material, it increases. So however, we cannot increase a distance between the contacts more from certain level. Why we cannot increase the distance between the circuit breaker contacts, I mean fixed contact and moving contact up more than certain level? Because we have to reclose it again. We have to make the circuit again. So If we have to make the circuit again, then making of that circuit takes more time. The re-energization of this breaker will take more time. The spring or the motor has to do more work. So therefore, we cannot increase the distance between the electrodes or the contacts of the circuit breaker up to certain level. So yes, we have to increase, we have to left a distance between both of them when they are open, but that distance should be set in certain optimum value so that it should not be a large one, it should not be less one. So it should be set up to have a certain optimum value. So, but it is a fact that if we increase the distance between the electrodes or the contacts of circuit breaker, it's the material dielectric strength increases. So at 1 bar, if you look at here, it is air at 1 bar. So the dielectric strength of air is least at 1 bar. However, the dielectric strength of vacuum is high, is extremely high at 1 bar. The dielectric strength of oil is less than vacuum, and SF6 gas used in circuit breaker is less than oil as well. So at 1 bar atmospheric pressure, the vacuum circuit breakers take the lead and they have the highest breakdown voltage. However, at 5 bars, if we increase the temperature, the SF6 circuit breaker has no match, and they basically bypass all the circuit breaker and the quenching materials used in the circuit breaker, and they have the best results and they have the high value. So by increasing the pressure, we also have high breakdown strength. And this is why, because by increasing the pressure, the dielectric strength increases. By increasing the pressure, the deionization time of the gas also increases. So I hope this graph is understood to you. And I hope there is not any problem in understanding this graph. So the same thing is indicated here with in the table form. For if we have a gap of 10 mm, I mean between the electrodes, so the air will break down at 30 kilovolt. Uh, SFC, SF6 will at if we have a pressure of 1 bar, SF6 will break out down at 60 kilovolt, and oil will break down at 110 kilovolt, vacuum at 170 kilovolt, and SF6 if we have a pressure of 5 bars, then the breakdown value of SF6 will increase up to 250. So what is this breakdown value? The breakdown value basically indicates the value of the uh, surrounding around the contacts at which or the I mean the value of the quenching material or the dielectric available in the circuit breaker, the value of the voltage at which the plasma start forming. So in case of air circuit breaker, the plasma start forming at 30 kilovolt if a pressure is maintained 1 bar. However, in case of oil and vacuum, the plasma will start forming at, or the arc will start forming at 110 and 170 kilovolt. So, and in case of SFC, at 1 bar, 60 kilovolt, and 5 bar, at 5 bar, it around 2. So this clearly indicates that at 1 bar, the breakdown value of vacuum circuit breaker is far more higher than the other circuit breakers. And it will break down at 170 kilovolt. However, at 5 bars, SFC circuit breakers have the best results. So application of circuit breakers, I will summarize here the circuit breakers based on their applications as well. So in arc furnace control, I mean the circuit breakers are used in arc brass burners, in tracking systems, in substations, in industrial processes, and these are the broad categories where the circuit breakers are implemented. Uh, so based on these categories, I have discussed them and what are the different type of circuit breakers that are used there. For example, if we take the example of arc furnace control, then arc furnace control up to which are usually rated around 11 kV to 33 kV. I mean, most of the arc furnace control are in this range of the voltages, and they have, I mean, a number of operations per day. I mean, they have to switch on and off and again and again. So, I mean, usually they have 25 operations per day. So they have a high frequency of switching on and switching off. So previously, there were ABCB, I mean, air blast circuit breakers were used there. But now the vacuum circuit breakers are used because of the high frequency of the switching. A vacuum circuit breaker can switch again and again, and you don't need the compressed air from the blast again and again to compress this air. So, secondly, the vacuum circuit breakers, I mean, their maintenance is easy. Uh, so these are the two main reasons that because of which the vacuum circuit breakers are being used instead of the ABCB. But in the older ones, we use the ABCB circuit breaker. ABCB circuit breakers are also used for the R furnace control if there are any furnaces with a voltage level of more than 33 kVs. I mean, there are some classical furnaces with very high voltage levels. There we use ABCB, I mean, air blast circuit breakers. Oil circuit breakers are usually not used in furnace controls because we have to perform various operations in case of because we have to switch on and off again and again. So therefore, for each switching of oil circuit breaker, the oil produces, I mean, decomposes into carbon, decomposes and then it produces carbon. And these carbon particles usually accumulates on the contacts of the breaker, which actually affects its affects its basically the performance. So to avoid this accumulation of the carbon on the circuit breaker contacts, we usually do not use OCBs or the oil circuit breakers in the R furnace control. Then we have single phase 25 kV traction system. These traction systems are usually used in railway locomotives and railway lines for the movement and the railway electric systems for the movement of trains, electric trains. So these systems were installed in Pakistan before from Lahore to Khanewal and in some areas of the India as well. So usually their vacuum circuit breakers are used. Again, ABCP was air blast circuit was previously used. However, now vacuum circuit breakers are used. And why vacuum circuit breakers are used? Because I mean, you know that they perform really well up to 33 kV, and we have here 25 kV systems. Secondly, they are small in size. They take very less space because we have these are installed usually in the locomotives and the power vans, and there we have less space, the modular power system equipment. So because of the less space and the small size of the VCB, and again they require less maintenance, and so therefore VCBs are preferable and they are used in the traction systems as well. Then we have capacitor switching. For capacitor switching, again we use vacuum circuit breakers. Um, why? Because we need a breaker which have high restrike free ability. I mean, because whenever there is a capacitor switching, there is always a restriking voltage. So we need a breaker that can avoid this restriking voltage. So vacuum circuit breaker has a very good quality of this. So therefore we use them mostly for the capacitor switching, and the capacitors are also and capacitors are usually installed in feeders and low voltage lines. So therefore, up to 33 kV these are used. But whenever there is a capacitor installed at a high voltage level, we will go for SF6 circuit breakers in that case. Now, EHV substation, in EHV substation, previously air blast circuit breakers were used up to 765 kV. However, now they have been replaced with SF6 circuit breakers because in case of SF6 circuit breakers, we do not require compressed air plant because for having a blast of air, we need to compress the air before. So the arrival of SF6 circuit breaker help us in avoiding this air blast and the compressors and the high motors and the big motors. So now in most of the EHV substations, SFC circuit breakers are installed. Furthermore, they require only one or two interrupters per pole. These interrupters I will explain in much detail when I will discuss about the SF6 circuit breaker. So now, based on these application, we can summarize these different types of the circuit breakers. I mean, here we have air circuit breaker, air blast circuit breaker. The air circuit breaker is the same one as air brake circuit breaker. So then we have oil circuit breaker, vacuum circuit breaker, and SFC circuit breaker. So the first feature is arc quenching medium. So in air circuit breaker, the arc quenching medium is air. Similarly, in air blast circuit breaker, it is air burst with but a high pressure compressed air. In oil circuit breaker, we have mineral oil, and vacuum circuit breaker, we use vacuum for quenching of the arc, and SF6 circuit breaker uses SF6 gas. Voltage ranges, the air brake circuit breakers are usually used in the range of 1 kilovolt to 15 kilovolt. Air blast circuit breakers are used up to 400 kV written here, but they can also be used up to 765 kV as well. But I have already discussed their challenges and why they have been replaced with SF6. Oil circuit breakers, they can be used up to 220 kilovolt level, where there is not frequent switching. Vacuum circuit breaker up to 66 kV, but yes, they can also use up to but maximum 66 kV is fine, but their optimum performance is around 33 kV. Then we have SF6 circuit breaker, medium to extra high voltage. They can be used at any voltage level, but they are usually used above 220 kilovolt or 132 kilovolt level because at lower voltage level they are not economical. Interruption speed for the air circuit breaker is moderate, air blast is fast. All circuit breakers are again fast, but vacuum circuit breaker is very fast. So where fast switching is required, vacuum circuit breakers are used. SF6 also has a fast switching. Dielectric strength, air has low, air blast has moderate, air oil has moderate, then vacuum circuit breaker is high, and SF6 is very high. So in dielectric strength, SF6 circuit breaker is the winner. Maintenance. So uh, frequent maintenance is required in air blast circuit breaker because we have, in this case, when we will discuss it in detail, but we have arc tubes and then we have arc splitters. So therefore, we need to maintain it at a very rapid rate. Air blast, again, high maintenance is required. We have to maintain the whole air system, compressor, and the motor. Oil circuit breaker, again, high because oil handling is not easy. Usually, it decomposes into carbon particles. Contacts circuit breakers, I mean, they become less effective in switching. Vacuum circuit breaker very low because there is no such thing in them. And again, SF6 has low, but again, the least maintenance required is by vacuum circuit breaker. Size and bulk. Compact, the air circuit breakers are compact. Again, air blast circuits are bulky because they have high, big tank for compressed air. Again, oil circuit breakers are bulky, especially bulk oil circuit breakers, because one of their type is also minimum oil circuit breaker. Vacuum circuit breakers are compact, and SF6 are also compact. Applications, they have low voltage application. Air blast have high voltage. Oil has also high voltage. Vacuum has low voltage or medium voltage, and SF6 have high to extra high voltages. So this is the comparison of different type of circuit breakers based on their features, arc quenching, voltage range, interruption speed, dielectric strength, maintenance size and bulk, and the application. So students, I hope this lecture is clear to you. We have discussed different type of circuit breakers in this lecture, and based on which criteria they are categorized into different types. What is the significance of each type, and